As we continue our unit on probability, today we're going to be doing the lesson called Visualizing with Venn, as we learn to create Venn diagrams a little bit more and how to use that data. We'll also talk about what the addition rule for probability is. So as we get started, if you take a look in your note sheet, we're going to really focus on Venn diagrams today. One of the attributes of Venn diagrams, it's easy to see the relationships within the data. So in this task, we'll create multiple Venn diagrams using data and determine the events that create those diagrams that either have an intersection or whether they are mutually exclusive, which means there's no overlap between the two categories. So here's some data that represents the number of men and women passengers aboard the Titanic and whether or not they survived. So your job is to create three Venn diagrams with this data, one that is men versus women, one that's women versus those survived, and one where you choose the categories. Then create a couple probability statements using those Venn diagrams. Let's do that first. So pause it and restart it when you're done with 2 and 3 and ready to see what I have. All right, so let's take a look at those Venn diagrams. First of all, men versus women. As we look at men versus women, we see that there were 805 men, 402 women. There were none that were both men and women. That's good. And there were none that were neither men nor women. So if we're looking at this one, we would say that these two events would be mutually exclusive. And here with the Venn diagram, it's easy to see what mutually exclusive is. We've got two categories where there's no overlap. It's either one or the other. If we're looking at conditional statements, we could say that 805 out of the 1207 total were men, or 402 out of the 1207 were women. Okay, the next one we looked at was women versus those who survived. We see there's 296 that were both women and survivors. So here we have some overlap. So these are joint. There's 146 that survived but were not women, 106 that were women that did not survive, and 659 that were not women and did not survive. Okay, so we can say, 659 were out of the 1207 were those who were not women and did not survive. We could count up the total survivors. Look in this circle. So we could see that there are, 452 or 442 that survived out of the total 1207. We can calculate how many total women there are, or how many women did not survive, the 106 out of the 1207, or 106 out of the total of 402 women. We can easily see how many did not survive out of the total, or how many did survive. So it's easy to see those with our Venn diagram. We can do the same thing with men and survived, and we can see that the majority were either men or they survived. Very similar to the women versus survived one. All right, so I'd like you to take a look at 4, 5, and 6 now. Create and label 3 different Venn diagrams using this data. Create at least one that's mutually exclusive and one that has an intersection. So mutually exclusive, there's no overlap. Intersection, there is an overlap between the two categories. So here's the data. Take a look at that and create a couple Venn diagrams using that. Then describe the conditions that create mutual exclusive Venn diagrams and those that create intersections. And what conjecture can you make regarding the best way to create a Venn diagram from data? It's going to highlight probabilities. So work on that and restart the video when you're ready. Okay, so as we take a look at this, probability of girls is 42 out of 100. That means the complementary event that they are a boy is 58 out of 100. And as we take a look at this also, probability not art is complementary to art, so that would leave 70 out of 100 that were not art. So let's take a look at the Venn diagrams that I created. Maybe you had some different ones, but here's the ones I made. I made girl versus boy. That's my mutually exclusive one. So 42 girls, 58 boys, no overlap. You're either a girl or a boy. That's how God made you. Next we have girl versus art. As we take a look at that, well, there were 42 girls. So we have that total together in the girl circle. When we looked at the total for art, there were 30 in art, so I have that total here. But how did I know how many were overlapping? Here's where I have this girl or art. That's where I use the addition rule. So girl was 42, plus art, which was 30, and then we subtract where they overlap because we don't want to count those twice. So there were 12 that overlap, which meant there's 12 that are girl and art. So that's where I get that number, and then that means there's only 18 left over who are art but not girls, and 30 left over girls that were not art. That means there are 40 left over who are boys but not art, because this whole section, this 18 and this 40, represent the boys. I knew there were a total of 58. And then art versus not art is another mutually exclusive one. You're for art or you're against it. You can't be both, so it's one or the other. So 30 for art, and then 70 not. So maybe you create a different Venn diagram, but those are the three that I made. Describe the conditions, create mutually exclusive Venn diagrams, those that create intersections. Well, mutually exclusive is two complements, one or the other, one or the other. Joint are two different categories that can have some overlap. The best way to create a Venn diagram to highlight probabilities, well, compare two different categories that can have some overlap. Because if we want to see, well, what's the probability that they are a girl or they like art, and we can look how many girls there are, 42, how many like art, 30, and that's 72. Subtract the 12 that are in common. Or with a Venn diagram, we can quickly say girl or art is these three circles. Or how many are not fans of art? Well, this is the art circle, so there's 30 plus 40, 70 out of the total. So we can compare those, and it's visually right there for us, and we can see that. So as you go through the assignment in class, just work you through some practice working with fractions, multiplying and dividing fractions, as you get into multiplying with probabilities. And then next part is creating two-way tables, Venn diagrams, and tree diagrams to help you record information and make note of it. And then another two-way table and writing conditional statements with that. So that's all we have for this lesson. Why don't you work through that? If you have questions, I'll help you in class.